Hello guys, I'm Shubham. Today I will be talking about rules and guidelines to make defect-free products in by injection molding. These are some of the everyday products that you see around us. Most of the plastic products we are using today are manufactured by injection molding. Almost one-third of the plastic and composite products are manufactured by injection molding. For some of you who don't have any idea about what injection molding is and how it works, let's see this animation. So there are the four steps involved in injection molding. First is mold closing. Second is the mold and plastic gets injected into the mold. Then the screw retracts and gets ready for the next shot. Then the cooling of the product, and then the ejection of the product. So this way the large number of the plastic product can be manufactured using injection molding and fully automatically. Thus, injection molding can be used when we have the thin plastic part. We want to do mass production. Of course, product size has to be small. Now question comes, so large variety of the plastic product I see around me, and what are the injection molded and how is the possibility and how to make such a product and how to design them. Based on the experience of the experts and the few guidelines that we have in literature, I will be summing up here about how to manufacture a defect-free injection molding product. One of the most important consideration must be that of the wall thickness. It must be within 0.5 mm to the 5 mm. It has to be uniform. Smaller the wall thickness, less the cooling time, larger the production in smaller time, and higher the profit. Hence, out of these four designs here, this is the thicker design, and we want to have this kind of design which is uniform and thin. Again, if design demands thick section, transition from the thick to the thin part must be uniform. Sometimes core can be used to provide uniform wall thickness. As you can see here, core is provided, and this figure shows that this is the non-uniform transition, but we must have this kind of transition. If we don't have uniform wall thickness, it leads to warpage in original design. As you can see here, this is as designed and this is as molded. So the main remedy is here that the product can't take high stresses generated during cooling, and to reduce the stresses, either we have to provide gussets like this here, or we have to provide ribs like this. Ribs provide high bending stiffness. As bending stiffness is directly proportional to moment of inertia, ribs provide large moment of inertia, results in large bending stiffness. Standard designing practice for rib can be seen here. This figure gives the detailed design for the rib designing. As you can see here, the orientation of the rib is very important factor based on the load, and the second orientation that you can see here, this will provide the good stiffness. Other than side walls, we can have non-uniform wall thickness at corners, so we need to take special care when designing any corner. Stress concentration can occur at corner, so we provide curve shape at it. Standard design requires inner radius to be at least half of wall thickness and outer radius to be at most 1.5 times that of the wall thickness. Till this point, we were talking about general important features of any product. Now we have designed product, but the fourth step in the injection molding cycle was that of the injection of the product and after the solidification of the part, so that we need to provide a draft of 1 degree to the 2 degree to every product. And if the design does not permit draft, then some other mechanism to remove product must be designed. Okay, now we have designed a basic product and we are also able to take that product out from the machine. Now, based on the demand and some added feature we need in our product like bosses and hinges, we have to have some special designing features for those kind of products. In case of bosses, they are used mainly to ease assembly. These two designs are not acceptable. This one is because non-uniform wall thickness, and in this we do not have any support for the structure, so its straightness is not guaranteed. These structures can be easily modified between one of these three, and standard dimension of any bosses structure is given here in parametric form. Another useful feature is hinge. Here this is the design of lunch box, and you can see hinge over here. In this hinge, you must have the fatigue strength, as it will open and close for large number of times. So this is the non-uniform structure, and we must have the cross section that that has to follow such a dimension, so all the complexity is taken care of if we design every hinge like these using these standard parameters. Only we have to take care of the material we are using. The material must be flexible. After all these designing features, now you have to choose the machine for your product and place the order. Machine limitations are displayed on the screen and you would like to have a look at it before you place your order. That's from my side. Thank you.